Welcome to Max World. Today we have seen the topic is f of x and pi of x denote respectively the distribution function and the characteristic function of the random variable x, and if x plus h and x minus h greater than or equal to greater than 0 or a continuity point of the distribution function f of x, then we prove that f of a plus h minus f of a minus h, which is equal to limit t tends to infinity integral minus t to plus t sin ht by t e power minus ita uh, pi of t dt. Now we have proved that f of a plus h minus f of a minus h, which is equal to this term limit t tends to infinity integral minus t to plus t sin ht by t into t e power minus ita pi of t dt. We have the given they have given characteristic function, right? Now we have to prove that only continuous type. Okay, our density function is f of x, we have denoted to j. Okay, so we have denoted to the RHS equal to j on the proof. Let me take this term. Okay, j is equal to 1 by pi minus t to plus t sin ht by t e power minus ita pi of t dt. Now we have already known that the characteristic function definition. In our characteristic function pi of t, especially the continuous type characteristic function, continuous type of the random variable, right? This continuous type formula is minus infinity to plus infinity e power itx f of x dx. We have substitute that, and next step, this integral goes to out like this, minus infinity to plus infinity sin h by t e power minus ita e power itx f of x dx into dt. Then we have the another step. We note it e power base or same, so we have added like this step e power minus ita into x minus a, right? E power it into x minus a. Okay, and another step, we have interchanging the limit. So first we have interchanging the order of integration, so the d's goes to inside and my infinity goes to outside. This is the first line. So next line, since the limit of integration with respect to t or finite, we have differentiate with respect to t, integrate with respect to t, that term become finite term. Okay, and another one, the interval is absolutely convergent with respect to x. Okay, the term we have taking the absolute value, we get the interval will be absolute convergence with respect to x. Okay, so first we have taking the absolute value for the RHS only this term with respect to x, so which is equal to this term. We have already know that e power itx, so for anything modulus we get 1. So next term we have neglected, which is equal to this, and another term sin ht by t, which is equal to t, which is less than h. We have assumed that, and another term we get this term, right? This term we have already known that 1, so h of 1 is 1, which is equal to h. We have taken the absolute convergence value with respect to x on the interval, we get this term. Okay, next we obtain, continuing to this step, j is equal to this term minus infinity to plus infinity minus t into t sin h t by e power minus e power I t a x into a, sorry, e power I t into x minus a f of x dx. We have interchanging the order, right? So dt outside dx. Okay, we have seen that t infinity order will be changed. And next step, sorry, wrongly 2 is here, step we have neglected, and we have seen this step alone, sorry. And 1 by pi minus t2 plus t, this term e power I theta, we know that cos I theta plus I sin theta, so we get this term, so cos x minus a into t sin x minus a into t. And next step, this go to intersect. Okay, so we have interside, we get this step. Next, this step tends to 0, we note it, because since it is a odd function, so it tends to 0. And another one, we seen that this term 0, so we get only alone the first step. So first step, sin ht by t cos x minus a into t dt, right? And we have the formula, right? Sin a cos b is equal to 1 by 2 sin of a plus b sin a minus b, so we get this term. And minus t to plus t, we have changed it 0 to t into 2. And next step, we get outside, and we have the formula, right? 1 by 2 a we have h, b we have a we have x minus a, b we have h, so we get this step. And this 2 and this 2 will be cancelled, and finally we get this solution. Then 1 by pi we have multiplied inside, so we get this step. Under the braces we have denoted g of x comma t, capital T. Okay, it's important. And we have split it, this term is g of t. The expression of the braces we already noted, it's the mathematical analysis term. Okay, and we have integrated, it is bounded, so the t greater than 0, and it is converges to pi by 2 and t tend to plus infinity. This is also same for this case. Sin, we get sorry, I have missed one t. Okay, so we get this term will be x, we have considered to be x. Wait a minute. Now we have c, I have missed 1 divided by t, sorry. So we know that sin, we have assumed that this term will be x minus a plus h. Okay, x minus a plus h will be considered x, divided by we have t, so into dt we have already known it, so it is bounded, so we can say that my g of x comma t also bounded. Okay, now we have considered it is bounded, mean my limit t tends to infinity, right? Because it is converges to pi by 2, and my limit t tends to infinity. So sin alpha t by t into dt, we get two values. When my alpha greater than 0, I get 1 by 2. When my alpha is greater less than 0, I get minus 1 by 2. we know that it is uniformly converges and converges uniformly, sorry, and with respect to alpha we get the, because it is a bounded value, it is a absolutely converges also, right? So taking modulus we get alpha value in terms like x minus a plus h and minus h also. So we get plus or minus h, right? So we say that alpha is equal to x minus a plus or minus h. When my delta is greater than 0 terms, we have this term, right? And the modulus of x minus t, x comma t, that term taking the limit, we get these intervals, okay? So then we have find actually j, right? So we have applying the t tends to infinity in j, we get the RHS this term in applying limit, we have substitute this value like 1. So alpha plus h and alpha minus h, we have this term, and finally we have substitute x place a plus h minus of x minus ah. So this is the limit t tends to infinity j, we get f of a plus h and minus a minus h. This is only for proof in continuous type alone. We have also the discrete type also. Discrete type we have write it in exam time. Similarly we get the discrete type also, hence prove the theorem. We have seen that this is one of the important question.